create a flow using the read and write to a GPIO pin on our ESP32. So let's start off with the first flow. So we start off with the on interval node. I'm going to keep the interval as 2 seconds. Then let's connect the write node to it. So this is a write node, which is also an activity node. As you can see, if I double click on it, we can see the properties of the write node. So the first parameter is the pin number, so which is basically the pin you want to write to, and the second is the pin level, which should be 1 or 0. 1 is for high and 0 is for low. So the pin number which you want to write to and the value which you want to write to the pin, those are the two parameters. Now let's set a delay loop right here for 1 second, and in this program I'm choosing pin 2, which is the internal LED of our ESP32. So when I write 1 to it, the LED should turn on, and I have created a delay of 1 second after it. And now let's write 0 to the same pin, which would turn off the LED, and in turn making this a blinky program using the internal LED of our ESP32. This is our first flow which uses the write, and then I'm going to create a separate flow using the on interval and reading from our pin 0, which is the boot button. So if we double tap on the read node, you see that in the properties there is one parameter which says pin number, and here our pin number is 0, which is the boot button of our ESP32, and the mode is pull up only, because the boot button, if you go to the datasheet, you'll see that it is a pull up only pin, and so that's correct. And now let's print the value of the GPIO 0 on our serial monitor. So as you can see, once I selected it, automatically gives me the option to print the pin level, and let's print pin 0. So this would print pin 0 is equal to and the value for the pin, and this is our flow, and we'll upload it to our ESP32 in just a second. But these two operations are very useful for in any program, as you often need to read and write to your microcontroller to perform various tasks, and it is also very helpful in various communication protocols as well, and for basic tasks such as blinking an LED as well. So for example, in a real use case scenario, if the temperature of a thermometer goes above 50 degrees Celsius, you can blink or turn on a red LED or the internal LED of your ESP32, which would be like a user interface, and the user can see visually that you have reached a certain threshold in our case, and there might be various other uses for this as well. So these two are extremely important operations which are performed, and the most common operations which are performed on the GPIO. Now let's upload this to our ESP32, and I'll show you the output in just a moment. Now let's check the output for our program. As you can see, the pin 2 internal LED is blinking, so the writing is working correctly. And now let's connect it to our ESP32. Let's see the serial monitor. And we connect it, and as you can see that currently the pin number, which is the boot, is equal to 1. And now when we press it, and I'm holding it right now, as you can see, it has gone low after the button press. So it's reading correctly as well. Now I've left it and it's 1 again, and if I press it again, you'll see that it's 0. So this is how the read and write work.